In this video, we're going to talk about quantum numbers. There's 4 of them that you need to know. And basically, the quantum numbers tell you the address of an electron inside an atom. Every electron has a unique set of 4 quantum numbers based on the Pauli exclusion principle. The first one is n. N is the principal quantum number. And n is an integer, 1, 2, 3, 4, and so forth, and can be 0. The principal quantum number describes the energy level of an electron inside an atom. So looking at the picture on the right, we basically have a Bohr's model of the atom. And we can see that the first shell represents the first energy level. The second circle is the second energy level where n is 2. And the third circle is the third energy level where n is 3. And so that's the first number you need to be familiar with, the principal quantum number. Now the next quantum number that you need to be familiar with is the angular momentum quantum number. This number is indicated by the symbol L, and it describes the shape of the sublevel within an energy level. Now we have 4 different sublevels that you're going to see on a regular basis. The first one is the S sublevel, which is basically a sphere. The second one is the P sublevel. And then we have the D sublevel and the F sublevel. Now what you need to know is that for the S sublevel, L is always 0. For P, L is 1. For D, the angular momentum quantum number is 2. And for F, L is always 3. Now let's talk about the relationship between N and L. L is less than or equal to n minus 1. And L and N are both integers. So let's talk about what this means. When n is 1, L can only have one value. That's n minus 1 or 1 minus 1, which is 0. Now when n is 2, according to this equation here, L has to be less than or equal to n minus 1 or 2 minus 1, which is 1. So that means L could be 0 or 1. And this expression will be true. Now what about when n is 3? When n is 3, the maximum that L can be is 3 minus 1 or 2. So L can be 0, 1, or 2. When n is 4, L could be 0, 1, 2, or 3. Now let's think about what this means. So remember, when L is 0, what sublevel do we have? When L is 0, this corresponds to S. Now when n is 2, L could be 0 or 1, which means that we can have the S or the P sublevel. When n is 3, L could be 2, so we can have the S, P, or D sublevel. And when n is 4, we can have the S, P, D, or F sublevels. Now notice that there's no 1p sublevel. This does not exist. The first energy level doesn't have the p sublevel. And let's say if you were to write the electron configuration for an element, you'll know that there is no 2d sublevel. You have 2s and 2p, but not 2d. In the third level, you could have 3s, 3p, 3d, but not 3f. So 3f is not possible. Now you could have 4f, that's possible. Now here's a question for you. Let's say we have an electron in the 3d sublevel. Based on that information, what is the n value and the L value that corresponds to an electron in the 3d sublevel? N is basically the number that you see here. So n is 3. Now for the d sublevel, L is what value? So if you recall, for the S sublevel, L is always 0. For the P sublevel, L is 1. For the D sublevel, L is 2. And for the F sublevel, L is always 3. So for the 3D sublevel, N is 3 and L is going to be 2. So let me give you another example. What if we have an electron in the 4f sublevel? What's n and what's l? As we can see, n is the number in front of f, so n is 4, and f always corresponds to an L value of 3. So for an electron in the 4f sublevel, n is 4, L is 3. Now let's move on to the third quantum number, which is the magnetic quantum number, represented by the symbol m sub L. This number describes the orbital within a sublevel. An orbital is basically a region in space in which the probability of finding an electron is very high. In an orbital, an electron can have an upspin or a downspin, and so every orbital can hold a maximum of 2 electrons. But now let's talk about the relationship between L and m sub L. So as we said before, L is the angular momentum quantum number, m sub L is the magnetic quantum number. So when L is 0, we have the s sublevel, and ml can only be 0. When L is 1, we have the p sublevel, and the p sublevel has 3 orbitals. The first one has the ml value -1, the second one is 0, and the third one has an ml value of 1. When L is 2, we have the d sublevel, and there are 5 d orbitals: -2, -1, 0, 1, and 2. When L is 3, we have the f sublevel, which has 7 orbitals: -3, -2, -1, 0, 1, 2, and 3. So what you need to know is this. ml is between -L and L. So let's say if L is 4, that means ml will be an integer between -4 and 4. So it could be -4, -3, -2, -1, 0, 1, 2, 3, 4. So this expression shows the relationship between ml and L. So let's say if we have the 1s sublevel, s only has 1 orbital. And for s, L is 0, and ml, which is this number, will also be 0. Now let's say if we're focused on the 2p sublevel. P has 3 orbitals. Now for 2p, we know that n is 2, and for p, L is always 1. Because L is 1, ml could be -1, 0, or 1. And so as you can see, the ml values, they correspond to the specific orbitals within a sublevel. Now let's say if we have the 3d sublevel, where n is 3 and L is 2. Now the d sublevel has 5 orbitals, which means that it can hold a maximum of 10 electrons, because you can put 2 electrons per orbital. Since L is 2, ml could be anywhere from -2 to 2, and so each ml value corresponds to a specific orbital in the sublevel. Lastly, let's go over 4f, where n is 4 and L is 3. The f sublevel has 7 orbitals, where ml can vary between -3 and +3. So hopefully this helps you to see the relationship between L and ml, which gives you these numbers. Now the last quantum number that we need to talk about is something known as the electron spin. The symbol that corresponds to this is m sub s. Now the electron spin could be one of 2 values, positive or -1/2. Now recall that an electron within an orbital can either be going up or down. So if it's going up, the spin is +1/2. And if the arrow is going down, the electron spin is -1/2. So that's the last quantum number that you need to be familiar with. Now let's say if we have the 3d 8 electron. What are the 4 quantum numbers that correspond to the 3d 8 electron? What would you say? Well, we know that n has to be 3 based on this number, and for the d sublevel, L is always 2. Now we know that D has 5 orbitals, and so the ML values will range from -2 to 2. Now we need to find the location of the 8 electron. The location will tell us the ML value and also the MS value. Now MS will always be either positive or -0.5, which I'll explain shortly. So let's start with parallel spins facing upward. So this is 3D1, 3D2, 3D3, 3D4, 3D5, 3D6, 7, 8. So the 3D8 electron, it landed in this orbital where ML was 0. Now we have a down arrow, which means the electron spin is -1/2. But now you might be wondering, okay, what if we started with down arrows as opposed to arrows facing upward? So this won't affect your ML value, but it will affect your MS value. So this is 1, 2, 3, 4, 5, 6, 7, 8. In this case, the 8th electron is still in the same orbital, but this time it has an upward spin of +1/2. So this can vary. This can always be either plus or -1/2, depending on how you draw it. But these three numbers will be consistent. N is 3, L is 2, and ML is 0. So that's basically it for this video. For those of you who like it, feel free to subscribe if you haven't done so already. And don't forget to click on that notification bell. In addition, for those of you who want a more deeper review of quantum numbers with more examples and practice problems, including those with electron configuration, I'm going to post a few links in the description section of this video. And when you get a chance, feel free to take a look at that. So you're going to have other resources on this topic. Thanks again for watching.